Om Swastiastu. Salam Harmony. Hello everyone. As you can see on your screen, today the lesson is mathematical logic. Let me introduce myself. My name is Cita Prasanti. My 3-digit number is 072 from 4A class. Okay, I will explain about three topics. The first is about definition of mathematical logic and the proposition and open sentence. And the last one is mathematical logic operators. So, let's start our lessons today. Do you know about mathematical logic? Maybe all of you familiar with logic and mathematics, but mathematical logic maybe is something new for you. Okay, mathematical logic is method of reasoning, provides rules and technique to determine whether an argument is valid. Mathematical logic is used in everyday life, but there is a little bit difference between logic and mathematical logic because in mathematical logic there are rules and technique. Next, about proposition and open sentence. Definition of proposition. Proposition is a sentence which can explain something true or false. Proposition can also be called statement. Proposition cannot be true or false at the same time. For example, 2 is a prime number. This statement is true. And then 5 is a prime factor of 21. This statement is false. Let's move on to the open sentence. Definition of the open sentence. A statement that contains at least one blank of unknown and that become true or false when the blank is filled. For example, x minus 5 equal to 8. If x equal to 7, the sentence is false. But if x equal to 13, the sentence is true. So I think it's clear that difference between proposition and open sentence. Now we learn about mathematical logic operators. There are several operators, namely negation, conjunction, disjunction, implication, and be-implication. The first is negation. The negation is a statement is the opposite of the given mathematical statement. The symbol to use to represent the negation is a statement are like on the screen. Now see the truth table. P is true. The negation of P is false. P is false. The negation of P is true. For example, P is 2 is a prime factor. The negation of P, 2 is not a prime factor. And there is the statement of negation. A or B, the negation is not A and not B. A and B, the negation is not A or not B. If A, then B, the negation is A and not B. For all x, AX, the negation is there x such that not AX. And then the last one, there exists a such that AX, the negation is for every x, not AX. Next, conjunction. A conjunction is a statement formed by adding two statements with the connector and the symbol for conjunction is like on the screen, which is can be read and. The statement P and Q is true if both of P and Q are true. Otherwise, P and Q is false. There are two premises, P and Q. So the truth table is 2 squared, which is 4. Now see the truth table. P is true, Q is true, P and Q is true. P is true, Q is false, P and Q is false. P is false, Q is true, P and Q is false. P is false, Q is false, P and Q is false. Example, premise P, Jakarta is raining. Premise Q, Jakarta is flooded. Jakarta is raining and Jakarta is flooded is true. Jakarta is raining and Jakarta is not flooded. It's false. Jakarta is not raining and Jakarta is flooded. It's false. Jakarta is not raining and Jakarta not flooded. It's false. Next, disjunction. A disjunction is a statement formed by adding two statements with the connector or. The symbol for disjunction is like on the screen, which can be read R. The statement P or Q is true if at least one of the statement P and Q is true, otherwise it's false. Now see the truth table. P is true, Q is true, P or Q is true. P is true, Q is false, P or Q is true. P is false, Q is true, P or Q is true. P is false, Q is false, P or Q is false. For example, premise P, today is cloudy. Premise Q, today it will rain. Today it's cloudy or today it will rain. It is true. Today it's cloudy or today it will not rain is true. Today is not cloudy or today it will rain. It's true. Today is not cloudy or today it will not rain. It's false. Next, implication. The implication connective, like on the screen, is read if P then Q. There P is called by hypothesis and Q is called by conclusion. Now see the truth table. P is true, Q is true, if P then Q is true. P is true, Q is false, if P then Q is false. P is false, Q is true, if P then Q is true. P is false, Q is false, if P then Q is true. For example, premise P, the power blackout. Premise Q, the room is dark. If the power blackout, then the room is dark. It's true. If the power blackout, then the room is not dark. It's false. If the power not blackout, then the room is dark. It's true. If the power not blackout, then the room is not dark. It's true. Next, the last is B implication. The B implication are B conditional connective, like on the screen, is read P if and only if Q. Intuitively, either both P and Q are true or neither of them. Now see the truth table. P is true, Q is true. P if and only if Q is true. P is true, Q is false. P if and only if Q is false. P is false, Q is true. P if and only if Q is false. P is false. Q is false if P and only if Q is true. For example, P. Ali passes the test. Q has scored more than 18. Ali passes the test if and only if has scored more than 18. It's true. Ali passes the test if and only if not has scored more than 18. It's false. Ali not passes the test if and only if has scored more than 18. It's false. Ali not passes the test if only and not has scored more than 18. It's true. Okay, that's all my presentation about mathematical logic, and I'm sorry if I said something wrong. Santi, 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 Thank you, everyone.